Alright, now that you've seen that little animation, here is the limit definition of a tangent line. I'll give you guys a moment to pause it, copy it down. So this is sticking with limits. It's saying that the limit as h approaches 0, f of a plus h, again, a is going to be a value for like x is equal to 2 or x is equal to negative 3, whatever. So f of a plus h minus f of a, all divided by h. So this is what the definition is. And here is an example. We're going to find the tangent line slope to this function at x is equal to 1. So sticking with my definition here, I want to basically find the limit of this function using this formula or this definition. So setting this up, it's going to be the limit as h approaches 0. It's going to be f of 1 plus h. Again, I'm replacing a with x is equal to 1 minus f of 1, all divided by h. So what this means is I'm going to take 1 plus h and plug it into this function. So it's going to be a negative parentheses 1 plus h squared plus 6 times 1 plus h minus, I'm going to put this in a bracket, negative 1 squared plus 6 times 1, close the bracket, all divided by h. Let me include my limit notation here, because limit notation is important. Okay, so then I have to actually go through and simplify this, because a quick check, if I plug in 0, it's going to be 0 over 0. I'll give you a moment to pause it if you need to, but trust me, this turns out to be 0 over 0 when you let h equal 0. Alright, so what I have to do is I have to expand this. I have to expand 1 plus h. So quickly I can do this on the side. 1 plus h squared is going to be 1 squared is 1. 1 plus h times 1 plus, or plus 2h plus h squared. This is what you get if you expand it. So it's going to be negative parentheses 1 plus 2h plus h squared. I'm going to go ahead and distribute this 6. So it's going to be 6 plus 6h minus. Now inside of the brackets, it's going to be negative 1, because the negative is out on front of the parentheses, plus 6, so it's going to give me a 5. Okay, all being divided by h. Next thing is I'm going to distribute this negative into the parentheses, so it's going to be a negative 1 minus 2h minus h squared plus 6 plus 6h minus 5, all divided by h. Now here's where I can go ahead and start simplifying this. Notice I have well, negative 1 and negative 5, and then I have this positive 6, so I can kind of think about those simplifying out. Combined like terms, I have negative 2h, positive 6h, so this simplifies to 4h minus h squared all over h. There's a common term of h that I can factor out, so it's going to be 4 minus h all over h. Again, I can reduce these out. Now when I'm reducing them out, I'm just going to put a 1 in its place, and then now I can finally reevaluate my limit. So my limit as h approaches 0 of 4 minus h is equal to 4. So this whole limit process gave me the answer of 4. So that means that the slope of the tangent line at 1 to this function is equal to 4.